Technically, there's 1 minute left, but we'll go ahead and get started. So this is the practical implementation of machine learning talk. And let me get things actually working. I'm James Sacra, so I am a JavaScript enthusiast. Most of you might know me from the local community. I've been involved in the meetups in the past, and I've been on the organizing group for this for the last 3 years. Right now, for my full-time job, I'm at Elsevier and their precision medicine initiatives. Sorry, I can't seem to get this to work right. Okay. So basically, I was a full-stack developer for more years than I'd like to admit, all in the .NET stack. About 6 years ago, I switched over to JavaScript, and I just loved it. I loved the fact that it's so advanced at times, and it has a low barrier to entry. So just about anybody, I've seen like artists and creative types come into JavaScript. At the meetup, there was a guy who put together like this music library as a musician, and he did like almost like a mini concert for the meetup. It was the only time I'd seen a standing ovation at a technical meetup, but it was really cool and worthy of that type of response. And you don't see that in other languages. You don't see a musician going in and saying, "Hey, I think I'm going to build a C# library to do this," or a Java library. JavaScript is accessible. It's easy to get into. I am not an ML specialist. I switched to the Precision Medicine Initiative at Elsevier about a month ago. I had about a month of prep where they basically said, hey, here's about 600 pages of documents to read on ML because you need to have a good understanding. So what this talk is really about is coming at from the angle of a JavaScript engineer to say, hey, here's what I learned about ML and here's what we can do with it. So I do have a huge task ahead of me in that I will be overseeing a lot of ML work for precision medicine, which if you're not familiar is amazing where healthcare is going. Very targeted healthcare, taking into account like even your genetic information in order to treat you. So Elsevier, since we're here, Elsevier is one of the big sponsors. I work for them. Basically, Elsevier is a healthcare information provider in the US. Our focus in the US is healthcare, but we're global. We have 35,000 employees, 52 different countries that we have offices in. We're literally everywhere around the globe. In Center City is our healthcare tech hub. So we have an office at 16th and JFK. We're still building it out. It's like this always evolving thing. There's always construction, it seems. But we are the 4th largest information provider in the world behind Google, so it's awesome. So kind of one of my favorite quotes, I'm not really a sports guy, but I do believe in pressing against discomfort when you look at something that you see as a challenge. Being able to say, hey, you know what, I'm a little scared of that, and then just saying, I'll take it on. So this is what most of 2016 has been in my company, and I'm sure it is in many others. Everybody wants to have ML or AI or whatever their term is that they think is the right word, but it's kind of a buzzword right now. Everybody wants it. Just like any other technical problem, you should look at it and approach it from the right solution. If it's easy to solve, that's not really where machine learning fits in. So it is a broad term. It's an evolving area, so it constantly means new things, and things that we didn't think were easy to do today, someone may solve tomorrow. So keep that in mind. But it really boils down to these items. I'm not going to read them since they're on the slide. And then the understanding is a wonky word, and we'll kind of talk about what that is. So starting with prediction. So this was like my first, let me see what I can do with the Amazon API, and they have a really great walkthrough on the links on the next page. So when I send out the slide deck, you'll be able to follow it. But what it is you give all of this data to the system and say, this is the expected outcome, or this was the expected outcome. You really have to train these algorithms. You have to say, this is the data that gave me the positive outcome. This is the data that gave me the negative outcome. And the more data you have, the better. So it's not like you just send it random information and say, hey, is this person going to buy my product? You have to start with something. And Amazon kind of did this so that you can do the walkthrough. There's files you can download And you can go in and see, are they likely to buy a product and what the probability is. So it's interesting information. NLP is huge. Like, everybody wants to figure out how to take all of this massive amount of text and do something with it. So from a summarizing text, why would you need to summarize text? So you have this huge product launch, and you start getting in a review here and there, and you're adjusting and you're managing this and you're reading through these things, and then you get more reviews and more reviews and more reviews. Eventually you can't process all of this information that you're getting. So what do? You need a way to turn that into something that's actually useful. I can guarantee that Amazon does not read every comment that everybody makes. It's probably not possible at this point. They're a huge company, right? So they have to figure out what's a favorable, what's something that's an alarm for them. So like if you add a review that says this product is nothing, like this is horrible, this was like not as advertised, hopefully they have somewhere in their system a way to say, oh, we should get involved. So how do they kind of do that? These are the basic steps. So you kind of turn a sentence into values. The easiest way to explain is called the bag of words approach. All words have equal value, except for stop words. We'll talk about that in a minute. And then you kind of score through things and rank the sentences. So this particular sentence is of more value than this one, and then you can select those and merge them. Obviously, that's like the most basic that you could be doing, and NLP takes into account more than just this. But from an explaining perspective, it's the concept. So plenty of dictionaries exist. You don't have to like type out all of the words in the English language in order for you to score this. And the stop word list is something that's important because these are words that offer little actual value to a sentence structure. And examples here, of course, and there's plenty. Can you create your own? Absolutely. Should you create your own? It really depends. If you work in an area that's very specialized, you may have to create your own. In healthcare, for example, we would have to, right? Because a lot of healthcare terms are not in a common dictionary. All right, it was working when I pressed the arrow before. Okay, so there are some challenges here. So as you go to approach NLP and think about some of the issues that you might have. So this is one. The first sentence, the important words would say, hey, this practical ML talk was exciting. People were looking forward to it. And then the second sentence changes what the perception is of the practical ML talk. So it's not as easy as just saying, all right, well, we'll select these and then merge them. You really have to do some work. And really, you have to understand your content. If you were trying to summarize Moby Dick, you can probably guess that a lot of the meat is throughout the book. But if you were trying to summarize a research paper, typically there's an abstract already in place, or most of the important information is at the top of the document for you. And you would have to weigh these things. Document categorization, I'm going to stumble over that word all day, is important, particularly for someone like Elsevier, who, again, fourth largest information provider. So how do you do this? So we have a simple algorithm here. You basically look at the recurrence of a term. If this article or this paper mentions dogs a lot, we can categorize it under dogs or puppies. Or it can be more complex. I had to work in puppies. So, or it can be more complex. So if there's something about eagles, is it a sport or is it an animal? Like, you have to understand the context of these documents to classify. Knowledge extraction is a key thing too, especially again in the healthcare world where you have a lot of literature being published. To be able to go through, like this example, Google Slides was easy to use for my presentation, although now I'm having issues. To be able to identify what the product is and what the benefit or the response is to the user. Obviously, super simple example, but take it more broad. Go back to that review example and think about things that you could extract from products that you've worked on. So data mining, an area that I should be more familiar with, if I'm honest, but going back again to the healthcare world, because that's what I know. You have all of these documents, these guidelines, these books, these journal articles that are coming out saying, here's what you should do to treat patients. Wouldn't it be great if all of that was used to build a decision tree dynamically? And that honestly is probably where we're going in healthcare in general. It's no joke. Like, I went through the algorithms and my brain like exploded. It's really deep, and if you're like a super scientist, then absolutely go through the algorithms and develop new ones. If you're like me and you really don't want to do that, there are plenty of like these common algorithms that the community of machine learning has embraced already. Image recognition. So this is a fun area because it's important and it's something that computers didn't do a while ago. And there are a lot of great APIs already. This is not something that I could really see us trying to, as a community, build a JavaScript image recognition library. I'm sure you could, but something like Watson exists already. There's AI API or whatever it's called. But you still have to train it. So if you're working on something that's completely new that Watson may not know, you have to come up with a bunch of images. It's got to be able to recognize this. So if you think about, here's 500 pictures of a cat. Okay, thanks. Here's a new picture. Is it a cat? And it's tricky because what if it's a corgi? Pointy ears, a little smaller, kind of looks like a cat. It's not perfect. So this is an area that, again, a lot of work has already been done in. I think that what's out there already today is fantastic. So you should check it out. It's cool stuff. So understanding is like my favorite part. What do we mean? Like, it's almost like philosophical at this point. Does a computer understand me? What is it doing? So you can think of it like a big mind map. So you're creating these relationships and these attributes. A cat is furry, in most cases. There are hairless cats. Pointy ears, whiskers, and then it can relate that to something else. Right? It has all of these attributes. So then we introduce the concept of a dog, the shared components. And then someone goes, hey, I like cats. And the computer can say, well, do you like dogs? And it starts to learn and grow this way. Is that really understanding, though, or is it a big mind map? And this is an area where I feel like we don't have to worry about robots taking over the world right now. It's, I kind of, reading through the ML literature that I've done, I was like, okay, I get this, it makes sense, it's not scary. And getting into machine learning, it was a lot of reading. But it kind of boils down to what can we do and what can we not do? And what would we like to do? Just like any other technology, right? So there are areas where understanding, especially around NLP, is like super challenging. So I printed my ticket and I put it in my wallet, but then I lost it. Did you lose your wallet or did you lose your ticket? The punch bowl was empty, but we were tired of drinking it anyway. What is it? It's not the punch bowl, it's the punch. But if you're thinking like a computer, you're trying to go back and reference the item. It's a problem. And then dummy pronouns. It's cold in here. What actually is cold? So someone mentioned earlier as I was running by this global scope. It is cold. This is the part that I find really impressive, is this concept of skip thought vectors. So ideally, machine learning will be able to take a book and you'll be able to delete a sentence and it will fill in with a sentence that makes sense in the context of the book. That's like a great goal, right? We're not there yet, but where we are is this concept of a skip thought. So you can see the example here where the machine learning algorithm has determined that Spot is something, and it did something, and it went somewhere. So Spot ran home. And this is actually something that is out there today that you can use. It's challenging to figure out where you would use this in the context of your application. and what problem it's going to solve for you. I mean, obviously, I don't know all of you very well, but every application is different. Summarizing text is something that I think a lot of people need to do. Skip thought, you know, what's the challenge? It goes back to that first slide. And it does get more challenging with complex sentence structures. This is like the basics that you would see in a kid's book. And it takes a lot to figure out just this. So neural networks, you can't have a machine learning talk without at least mentioning them. I could probably put together a talk that would last weeks on the topic of neural networks. I'm not going to. But it is a very deep world within neural networks. Like, there are various types. Each one does something slightly different. One of the challenges, I can think back to healthcare, is explaining the results. So if the machine learning algorithm that's based on this neural network comes back and says, hey, Dr. Shan, you should give your patient this drug at this dosage and this frequency. Well, great that we are able to do that, but the doctor's going to want to know, what research are you basing that decision off of? And if you're using these things to extract knowledge, and you have multiple documents tied together, and that it's basically saying, well, I learned this from this, and I learned from this from this, you can't go back to the provider and say, well, here are the 50 pages that we extracted this information from. It just doesn't work like that for humans. We want to understand, or when we want to understand the source, we need to really understand that source, particularly in like careful markets. So neural networks is a very specialized field too. It's not super challenging to get the basics. There are great walkthroughs and demos out there. In fact, I think we have time to pop one up that I will not be able to explain very well, but it looks cool. So the link is also on the next slide. And of course, I'll post all of this so that you can play with it. They do a better job of explaining what all of the little knobs and everything do than I'm going to be able to. Well, it's on one of the slides. We'll get to it. So where does JavaScript actually fit here? As you read through online and you talk about machine learning and JavaScript, you see two things. You see a lot of open source projects that people have put out there to contribute. And then you see a lot of people saying, why the hell would you do this in JavaScript? You know, we still get a little bit of that, you're not a real programming language. It's not true. We're a real programming language. Back off, guys. So there is a lot of base work already done by people who are like deep in machine learning and wanted to do it in JavaScript. Also, as part of the resources slide, there is an actual walkthrough. Add this line. This is what this line does, and it will walk you through creating some basic ML recognition or pattern in JavaScript using Node. So it's really cool. I highly recommend it. That's a 6-part blog series. And the line by line really helps, because most of us, when we really get into it, need to see the code to understand what we're talking about. And the examples that you see out there typically are done in Python or R, but it's just any other language, right? Just because you see that it's in Python or R doesn't mean you shouldn't pop it open and see what they're actually doing. So neural networks especially is an area where people say JavaScript is not the best fit because of the matrix math. There is already a library that exists that will let you do matrix math and vector math using the WebGL. So it kind of changes the way that it's going to process this. And that's kind of how a lot of why ML has progressed so far is using the GPU, more so than traditional processing. When you're building, and assuming that you're all going to go out and build some neural networks next week, right? So when you look out there at Amazon's AMIs and you say, I want to get started in machine learning, you'll notice the GPU is significant for that degree of processing. So this is actually, if I can figure out, oh, that's not hooked up. So this is the neural network in your browser. This is why, you know, one thing that you'll read is you can't do neural networks in a browser. The processing doesn't exist. And yet here we are. Here's a neural network that someone put together for the JavaScript community. And what you're doing is it's kind of plotting some data over here, and you're going to see this as we go through it. It's going to try and predict where the blue and the yellow dots will appear. And after, if I can actually stop that, it was about 80 iterations. It did pretty good. Like, that's a pretty solid thing. Now, you can change the pattern, and you can see the prediction happen with different patterns. And again, you'll see how many iterations you'll have to go through. Oh, this is not done yet. I think we have a problem with this one. But you get the idea that it will go through and figure out, like, based on this random set of data that we provide it, what is the expected input to happen. I liked this one because they kind of showed where it breaks down. That is not an easy thing to predict, right? So here's where we solved it in the first one. We had a pretty rough idea, I think, in the second one. We're still, you can kind of see it starting to swirl in the background, but it's still pretty clueless, right? It's not a great fit for everything, but we can go through and play around with these features. Sorry, let's reset this. Stop. And you can add different ways, like a bunch of different ways to process it and see how it responds. And who knows, maybe it'll do a better job this time. You can certainly see that there's more activity in the way that it's looking at this, but it still struggles getting the swirl down. It's pretty neat. I wish I could like blow this up to full screen and have some like disco music tied to it. What's that? Well, so you can start to see it's trying, and it's actually got this, which is pretty neat, and this. So it took us, when we added more kind of like ways to look at the data, it definitely did a better job. See if I can get back to my slide without. So definitely go play around with that, because that was pretty neat. And the more that you tinker with it, if you scroll down on that page, it will actually walk you through what those features and hidden layers actually are. And again, they're going to do a much better job than I'm going to do standing up here talking to you. So, like I said, there's a lot of libraries out there, a lot of examples. Why use JavaScript? Because you can, and you know it, and your friends know it, and your coworkers know it. And quite frankly, Node is powerful. I think that there are opportunities within the JavaScript community to look at things a little differently. So someone who's trained in R or Python isn't going to think about someone who's familiar with JavaScript in kind of that ground up, like almost like grassroots approach. When we were I was working on a project, and we had to do a lot of pre-processing and then a lot of post-processing, and then before it even goes into display. And because we were working in Node, we're like, let's just do all that processing first, and we'll just store the result. And that way we don't have to do it every time. And the people who were like the Java engineer experts were like, oh yeah, that makes sense, because we're so focused on optimization in the front end. You need speed, you need performance, you need people to be happy with the load time and the speed of which things render. These aren't things that are at the forefront of other types of developers necessarily. I mean, obviously they do focus on performance optimization. I'm not saying that we're solely the best. We are. But it's something that I think all of us were trained right from the get-go, especially those of us who were doing JavaScript back in like the 90s. And the community does something I think that we do better than other groups, which is knowledge sharing. A lot of us work on open source projects. A lot of us are active contributors. A lot of us attend meetups or organize conferences. We simplify a lot of the complexity, and we try to like say, look, this piece keeps getting rerun. Let's abstract it into a library and move on. And rather than having to like have someone else do it, we're like, just to save other people time, we'll drop it out on a repository somewhere. And like I said, unique approaches to optimization. We do tend to make things stupid easy, which I love about this community. So going back to the earlier part where we talk about someone like an artist or a musician who's coming into JavaScript, if they have access to these libraries, they don't need to know how they work. They don't need to look under the hood, right? They just need to know that I give it this and it gives me that. And that's the real power with our community, in my opinion, is the fact that we're so willing to share and we want to make it easy for everybody. And then you have like these amazing people from other areas saying, let's come in and do this. We might not be, the people in this room may not be the people who do the coolest thing with machine learning, but we might facilitate that. Or maybe you will. So to me, I think that we should kind of rally around this. We should understand what people want to do. We should understand how we do it within the context of Node and you know, the browser. And we should help kind of educate people on it as well. And not just each other. Like, going back to that first slide, let's use ML for everything. What? And we need people who are at least familiar enough with the basic concepts. Since most of us are front end or have access, like are in that group, we tend to be closer to the product, we're closer to the product owner, we're closer to the customers, and don't, you know, I hope that nobody devalues their voice in product development, because you're able to say, hey, I get that you think we need machine learning for this, but either we don't, or you're dead on, like let's put this together and build a project around it. Here's what I know that we can do, and here's the libraries that we can leverage so that we don't have to do everything from scratch. So since I'm running a little early, these are the links to the walkthrough. I'm actually going to like fire that up because it's really cool. And the reason that this guy said that he wrote it in JavaScript is because he was doing, everyone got tired of him switching languages. So he's like, fine, I'm going to do it in JavaScript because most people know JavaScript. But he does go through here, in somewhere in here, he's like, well, you don't want to really build neural networks in the browser because JavaScript can't handle it. And you know, we already saw some of the other areas where it does. Like we just saw a neural network in a browser. So he actually does walk you through like what all of these mean and step by step. He does talk about supervised learning, which I did kind of skip over or didn't mention at all. Supervised learning, if anybody's interested, really is the machine saying, all right, here's what I think it is, and a person saying, yes, you're right, or no, you're wrong, and letting the algorithm adjust accordingly. So I highly recommend walking through this. This is an excellent walkthrough for if you want to get into the meat. And that is the end of my presentation. Does anybody have any questions?
For like the learning part and the review of what the machine is returning, is it like purely like technology specialists kind of like reviewing and vouching for the decisions that the machine is coming up with? Or?
Do you mean specific with like the supervised learning process?
Yeah, like is it just like technologists reviewing the decisions that the outcome of machine learning?
So I'm going to repeat the question for the recording. The question is about, is it just technologists that's reviewing the results in supervised learning? The answer is no. Hopefully we will not be sitting at our desk going, yeah, that's right. No, that's wrong. That's incredibly boring. But hopefully you're working with specialists who do know the answer to that, and you're able to build like a validation project so that they can go in and say, oh, that is absolutely right, or it's like horribly wrong. Please don't ever show this to me again. Any other questions? Oh.
I assume the big issue with neural networks and JavaScript was a performance one. Has anyone been experimenting with cross-compiling C++ to JavaScript for that purpose, like using ASM.js?
So the question is around cross-compiling to overcome some of the performance issues. Not that I've found. So you mentioned, sorry, ASM.js, right? Yeah. And so I didn't look too heavy for that because I tend to be interested in the like this started in JavaScript and grew up that way, but it's worth a look. I recommend checking it out, see if you can find something. And if you do, please share it.
Maybe there's like inner loop stuff that should be done that way, and then the rest of JavaScript or something like that.
Yeah. Okay. Any other questions? Okay.
Would you mind going backwards, Lex, so we can take a picture of it?
Oh, sure. And I'll have this, I'll post it in the Slack channel, and I will have it in the, I'll post it to Twitter. I think there was another question.
I can see a lot of applications for being able to do natural language processing client side. Do you think that's feasible this time, or would it be too tough to haul the data set?
So the question is about doing NLP client side. I believe that to be feasible at this time, but it's going to depend on what it is you're processing. If you are trying to process a 500-page book, your browser's going to crumble, mainly just from the memory requirements of the processing. If it is probably like a blog post or something that's like 500 words, 750, you should be fine, depending on how you implement things like dictionaries and stop words. The bag of words approach is actually pretty nice for random content that you just want to summarize. So all you really need to store at that point is the stop words, the filler words, and ignore those. There is a project out there that's done that in the browser, and they created it as a Chrome extension, and then they removed it. Jerks. Because it would have been great to demo. Any other questions? All right. Well, thank you everyone for your time. I hope that you're having a great day, and I will see you at the end of the day again. In the meantime, you've got time for coffee and more snacks. Thanks.